Okay, question 45. Solve the following system of equations using any method. Check your solution if possible. All right, let's look at A. I say for A, I'm going to multiply the bottom equation. I'm going to multiply the bottom equation by -2. Okay, that's what my plan is. So if I do that, right, I'll rewrite the top equation. The top equation is just 6x minus 2y equals 10. Oh, my face is in the way. There we go. And the other equation becomes negative 6 times x plus 2y equals negative 4. Uh-oh. Uh-oh. You see what just happened there? If I add 6x and negative 6x, it's 0. And if I add negative 2y and 2y is 0. This just became 0 is equal to 6. That's not, no. That's not right. You know why? I bet these lines are parallel. Let's peek at these two lines. Let me pull up Desmos here. So if we're in our friend Desmos and we graph the top line, it was 6x minus 2y equals 10. Equals 10. There it is. There's the one. And let's graph the other one. The other line was 3x minus y equals 2. Aha! Just as I suspected. These lines definitely appear to be parallel to each other. And if I was to rewrite them in slope-intercept form, it would be really evident pretty quickly that they had exactly the same slope. So because they're parallel lines and they have different y-intercepts, they're never going to intersect, right? So that one, no solution. Yeah, there is no solution. There's no point where those lines are going to meet. Let's go back and, so for A, we say no solution. No solution. Let's look at B. Oh, okay. B. Wanted to do some substitution, maybe. That wouldn't be a bad idea. Or maybe we can make some things cancel out. I don't know, let me try this. I'm going to get y alone in the top equation, right? By adding 2 to both sides. So I get that 3x plus 2 is what y is. Okay, I got y. Now that I know what y is in terms of the first equation, I'm going to substitute that in for y in my second equation. So if I rewrite that, I got the 6x equals 4 minus 2 times open parentheses 3x plus 2. If I distribute that, it's going to equal 4 minus 6 times x minus 4. And over here, this is 6 times x. Well, do you see what's happening right here? Right? 4 and negative 4 is 0. So this is becoming 6 times x equals. This is an identity, right? You know what? I bet these lines are parallel, but I bet they have the same y-intercept. And because of that, they have, if one point is a solution on the top line, it will also be on the other line. They share all the same points. So let's look at that in Desmos. So in Desmos, we go that 3x equals y minus 2. And the other equation I'm going to write is 6 times x equals 4 minus 2y. Wait. 3x equals y minus 2. 6x equals 4. Oh, I'm wrong. What did I do? What did I do? I'm wrong. I mean, how I made a mistake. 3x equals y minus 2, and 6x equals 4 minus 2y. I did something wrong. Let's go back and look at that. First equation, I intended to get y alone by adding 2 to both sides. I think I did that successfully, okay? And then in the second equation, I had 6 times x equals 4 minus 2 times the quantity of 3x plus 2. Negative 2 times, I'm embarrassed. Clearly, 4 minus 4 is 0, but this is a negative 6x here, okay? And I know you're like, well, yeah, what's the difference? Well, it just changed things. Because now if I add 6x to both sides, this equation is going to become 12 times x is 0. Well, okay, therefore x is 0 divided by 12. X is the number 0. All right, x is 0. If I know that x is 0, then certainly 3 times x is 0, and 0 equals y minus 2. And if I add 2 to both sides of that, right, because this is 0 equals y minus 2. If I add 2 to both sides, 2 is what y is. So this has a solution at 0, 2. And I'm really glad that I looked at that in Desmos. So let's go confirm that. 0, 2. And in Desmos, yes, x is 0 and y is 2. That's the solution to that wonderful system of equations.